Hi, this is your video for 5-3 practice problems, and you're going to be taking a graph, a table, or a word problem and writing a function to go with it. You've done something very similar to this previously in chapter 4. We have a graph or something or some points, and we would write an equation in slope-intercept form. That's really what we're doing here. Okay, it's not any different. It's just, they're calling them functions now. Okay, so what I've done here is this is the problem as it appears in your workbook. It's on page 283. Here is also the actual problem from McGraw-Hill. All right, the graph looks very much the same, but they've got parts down here, and I'm going to tell you how to fill in those boxes once we arrive at a solution. Now, with this problem, my first approach on this one would be to make a table of values. Okay, so I would make an XY table. This would be 0.128. This would be 0.236. And this would be 0.344. Now, I would use the table to find slope. You could just take any two of these points and use the slope formula, but I kind of like the table. I always think that's easier. You ask yourself, how is this changing? Well, this is going up by 1. And how is the y changing? The y is going up by 8. Remember, you always put the change in y over the change in x. The simplest way to write a slope of positive 8 over positive 1 is to write a slope of 8. So I have my slope, but now I need my initial value. I need to know what y is when x is 0. Okay, well, I can find out by backing this backwards. Okay, if going this way I add 8 each time, to go backwards 1, wouldn't I subtract 8? I would. So 28 minus 8 would be 20, which tells me my initial value is positive 20. So my equation here would be y equals 8 for the slope, x plus 20 for the initial value. Okay, so when we go to enter this on McGraw-Hill, here's what we'll have. Oh, I guess it still shows up. There we go. Okay, so on McGraw-Hill, what you will do is it says the rate of change is 8. That's your slope. Okay, so the hourly rate is $8. All right, same number goes in those two boxes. It won't always be the case though, so you got to watch the whole video. The value for y when x is 0 was positive 20. So you just type 20. So the initial fee is 20. You don't type the little dollar sign because they put it in for you. Now down here they want the equation in the form y equals mx plus b. So here's where you would type y equals 8x plus 20. Okay, and that's number 1. This is number 2. We have a table. Okay, the table shows the distance Penelope is from the park as she walks to soccer practice. Assume the relationship between the two quantities is linear. Find and interpret the rate of change in the initial value, then write the equation. So this is set up the same way as problem number 1. They're going to have you fill in these little boxes, and then the part B, you'll have to give them the equation. Well, let's figure out what the equation is. First of all, I'm going for a slope here, or a rate of change. From here to here is an increase of 5, increase by 5, increase by 5. So my x is increasing by 5 each time. On the y, this is going down by, going to need a calculator. Grab a calculator. Can't do that kind of math in my head, not reliably. 1930 minus 1380. So that's a decrease of 550. It's going down by 550 each time. So slope is change in y over change in x. I've said that about a million times now. So we would put the change in y, negative 550, over the change in x, positive 5. Well, if you simplify this, you get negative 110. Why negative? Because the distance is getting less each 5 minutes that she walks. The distance gets shorter and shorter. Okay, so that's why it's a negative 110. So when we go down in here to put the answer in here, well, let me finish the problem. I know the rate of change is negative 110. So I've got this much of the equation. But what's the initial value? Okay, they didn't give us an initial value. Now, I'm not going to do 4, 3, 2, and 1 here because notice this is decreasing by 5 each time. And if I decrease from 5 to the next one, I'm going to be at 0. All right? This number is decreasing by 550, so the next step up would be increased by 550. So I'm going to take that number, 1930, and I'm going to add 550 to it, and that's going to give me 2480. Okay, that's my initial value. She was initially 2,480 feet from the park. Each 5 minutes she walks, she is 110 feet closer, which is why it's negative, because you subtract 110 feet from that number each 5 minutes. So what would we put in these boxes down here? All right. In this first one, the rate of change is negative 110. Now pay attention here, because the way this is worded over here, so Penelope is how many meters closer to the park every minute? This one will not be negative 110. This would be positive 110 because she is a positive 110 miles closer each time. Okay, so be careful of that. This first one has to be negative, but the second one is positive. The initial value, that's our y-intercept, that would be 2480. So Penelope was initially 2,480 meters from the park. Okay. And then down here, they would want you to write the equation in the y equals mx plus b. So you would type y equals negative 110 x plus 2480. Don't put spaces or anything, just y equals negative 110 x plus 2480. Now we have a skating rink. Skating rink charges a skate rental fee and an hourly rate to skate. The total cost to skate for 2 hours is $9.50 and for 5 hours is $18.50. Assume the relationship is linear. Find and interpret the rate of change and initial value. All right. Well, they've made this hard on us. I like using the table, but here's the problem. We have 2 $9.50 and we have 5 $18.50. So it's going to be kind of hard to know how this is changing every one. Okay, that's not easy for us to do. So what we could do is we could use the slope-intercept or the slope formula for this one. Remember, slope formula was second y minus the first y over second x minus the first x. Okay, well, this is first x, first y, second x, second y. So the slope, I put a y, I meant to put an m there, that's slope. The slope of this line would be second y, 1850, minus the first y, 950, over second x, 5, minus the first x, 2. Well, 1850 minus 950 is $9. And 5 minus 2 is $3. So the slope is 3. What that means is for every hour that you skate, they charge $3. Okay? $3 per hour. That is our rate of change. That's our slope. So we would write y equals 3x. But what's our initial starting value? Okay, they're charging a skate rental fee, and we don't know how much that is. Well, look at these numbers. If after 2 hours you paid $9.50, can we figure out what the skate rental fee was? Yes, we can, because every hour costs you $3. So if you skated for 2 hours, wouldn't that be $6? So how much of this is skate rental fee? Well, what would be $9.50 minus 6? It would be $3.50. So you would add $3.50 to the skate rental. Okay? And that's how I found it out. I knew that 2 hours I paid $9.50. So I said, well, for 2 hours at $3, that would be $6. So if I took away the $6, whatever's left is the skate rental fee. Okay? So what do we put in these blanks here? Let me put the blanks where you can actually see them. Okay. So the rate of change, that's how much you're paying per hour. The rate of change is $3 per hour. Okay. So the hourly cost is $3. These are going to be exactly the same. The initial value is $3.50. It will accept 3.5. I checked that. So the skate rental fee is $350. Okay, and then you write the equation in this box. It wants you to write the equation, and the equation is just y equals 3x plus 350, no spaces. All right. So number 4, a movie theater offers a reward program that charges a yearly membership fee and discounted rate per movie ticket. The total cost for a reward program member to see 5 movies is $40, and the total cost for 12 movies is $75. Assume the relationship is linear. All right, so this is what it looks like when they give you a word problem. All right, we've got movies, which is our X value, and we've got price or cost or whatever, total cost, which is our Y value. After 5 movies, you pay $40. After 12 movies, you pay $75, okay? And they're telling you that the relationship is linear. I think we really want to use slope-intercept slope formula again on this one to find out what the rate of change is, okay? So if we had, let's see, this would be second Y, this would be first Y. So second Y minus first Y over second X minus first X, 5. 75 minus 40 is 35. And 12 minus 5 is 7. And 35 divided by 7 is 5. So I know our rate of change is 5. Now what I need is the initial value. All right. So if I take this first one, for 5 movies, I paid $40. Let's take away, what would 5 movies cost me? 5 movies at $5 a piece would be $25. So if I subtract that $25 from the 40, whatever's left is the initial fee, okay? So that would be $15, and that's our y-intercept. Now, in the book, what they want you to do is they want you to use y equals mx plus b, and they want you to use one of these as an xy point and use that as b and solve for the other thing. What that looks like, y equals mx plus b. You can pick either point. Always pick the smaller point. This is the x, this is the y, and this is the m. So y is 40, m is 5, x is 5, and b is the thing we don't know. You would have 40 equals 25 plus b, and then you would subtract 25 from both sides, and you would have that b is 15. It's another way to arrive at the same solution. I think mine's a little simpler, but okay. You can do it with y equals mx plus b if you choose. In question 4, all it's asking you for is the equation, okay? So you're just going to write the answer y equals 5x plus 15. Okay. Anybody misses anything on this practice, I'm going to come hunt you down. And I'm going to tell your mom you didn't watch the video. Okay, number 5. And I think there's only 6 questions, so, oh, I thought I put that on the other thing. Number 5. Now, this is where it gets interesting, okay? Here, they're giving you the graph of 2 different houses in 2 different locations, and they want to know what's the difference in values of the 2 houses when they're 15 years old. This is going to have some steps to it, all right? As far as the question on McGraw-Hill, it looks like this, all right? And they're asking the same question, and they just want you to write the difference in price. They don't want the dollar sign because they put it there for you. So you're just going to type in the amount. Well, let's see. What is the amount? All right. Well, we have these 2 graphs, and we have house A is this tan one. What is this point? This point is 3,150. And this point is 8,180. Okay, so this is for house A. For house B, we're going to use the blue line. We have 1,130. And we have 5,150. Okay, so we need to get an equation for both of these guys. And then we need to use the equation to answer the question. We have to figure out how much they're going to be worth in 15 years, and then answer which one it was worth more and by how much. It's got some work ahead of us. So hope you're in a comfortable seat because this is going to take a minute. Okay, I'm going to use the slope formula. All right, second y minus the first y over second x minus the first x. 180 minus 50 is 30, and 8 minus 3 is 5, and 30 divided by 5 is 6. So our slope is 6, okay? So now what we can do is we can, first of all, we could do it the simple way. Let's take this first point. We know after 3 years, no, let's use the y equals mx plus b1. I think that'll be easier in this case. I don't want to complicate it any more than I have to. All right, so we're going to use y equals mx plus b. We have an m of 6, and we're going to use the point 3, 150. We use the smaller of the 2 points. So this is our x, this is our y, this is our m. Y is 150, m is 6, x is 3. What's b? Okay. So we have 150. 6 times 3 is 18. Then we subtract 18 from both sides to get b by itself. And we're going to get 132 is b. What does that mean? That means that originally house A sold for $132,000 because this is dollar value in thousands. So my equation for house A is y equals, my m is 6, x plus 132. Okay, it's going up by $6,000 every year, and it started at 132. Now on B, we're going to have to do the same thing. Second y minus the first y over second x minus the first x. So my slope, 150 minus 30 is 20, and 5 minus 1 is 4. So this one is changing by $5,000 each year. Okay, that's my m. Now let's use 1 point. Let's use the smaller one, 130. So we have an x and a y. Okay, and we're going to use y equals mx plus b to find the initial value, or how much the house cost initially. Now you're saying, why don't you just look at the graph? It's hard to tell exactly what the initial value was on either one of these houses, all right? That's why we're having to use this. So we have a y of 130, m is 5, x is 1, and we're trying to find what b is. So we have 130 equals 5 plus b, subtract 5 from both sides, and we get 125 is B. So house B is increasing each year by 5, so that's our rate of change, 5x, and its initial value was 125. Okay? So now we have our two equations. This is house B, and this is house A. But we're still not done, okay? They want to know what's going to be the difference in the value of the two houses when they're each 15 years old. So what you're going to do is you're going to substitute 15 for x in both of these equations. This one will be y equals 5 times 15 plus 125. And this one is going to be y equals 6 times 15 plus 132. All right. Well, let's see, 2 times 15 is 30, so this would be 90. And if I add 90 to 132, I get 2, 9 plus 3 is 12, carrier 1, 222 for that one. And on this house, 5 times 15, that would be 75. Plus 125. And that would mean this house will be worth $200,000. Okay, so what is the difference? Well, the one house is worth $222,000. The other house is worth $200,000. So the difference is 22,000. Now see, this one is tricky because you can't put 22 as your answer on this. They're asking you what will be the difference in the values when the houses are 15 years old, and what they want is they want the total money. They don't want 22. They're not going to be $22 different. These dollar values are in the thousands. So in here, you have got to type in 22,000, 3 zeros, people, and it will be marked correct with or without the comma. Just FYI. That's a lot of work for one problem. Aren't you glad I did it for you? I know, they don't pay me enough for this. All right, question 6, I believe, is the last question. I don't think there are any more than 6. But here we are comparing two tables, same kind of thing, all right? We need an equation for each table, and then we need to make a comparison where they're just asking us what will be the difference in cost of the two plans after 18 months, okay? So we're just asking for a cost, two plans, okay? I think we can use the table on this one because we're very close to 0 here. I'm liking that. We'll put a 0 here. We'll put a 0 here. This is going up by 1 each time. Nice and neat. How much is this going up by? Well, that would be 25 plus 10 would be 35. So it's increasing by 35 each time. All right. That would mean that to go this way, we would have to subtract 35 from 75, which would give us 40. Oh, this one's way easier. So the equation for this one is y equals, now the slope is 35 over 1, which is 35, and the initial value is 40. So that's the equation for company A. Let's go over here to company B. What's going on here? Up by 1, up by 1, up by 1. This one's going up by 50, up by 50, up by 50. Okay, so the slope is 50 over 1, or just 50. We need the initial value, though. Going up by 50 this way, if we're going to go backwards, we would go down by 50. So the initial cost is 10. Right? And it wants to know what will be the difference in the two plans' costs after 18 months. So we're going to let x equal 18 in both of these equations. So we have 35 times 18. Oh, that's a calculator problem. And over here, y equals 50 times 18 plus 10. Okay? Calculator. All right, so I'm with the first problem. I'm doing 35 times 18 is 630. 630 plus 40 is 670. Over here, I need 50 times 18, 900. And 900 plus 10 is 910. And they want to know what's the difference. So 910 minus 670. $240. And you're just going to type 240. This isn't 240,000 like in the houses. This is just $240. Okay, so just type in the 240. All right, is there more than that, or is that it? Yeah, no, that's all I put on the practice. See, from there, these problems go and get really weird and complex, and I don't want to go in that direction. Next week, we will be doing some more problems like these, but they'll be a little more straightforward and a little simpler. I know I pretty much did all these for you. The ones we're going to be looking at next week, I will not do them all for you. You'll have to do some yourself. But I wanted you to get the idea of what we're doing. So go on over to McGraw-Hill and do the practice. Like I said, it's only the first 6 problems. Make sure you're careful about how you enter the answers. And then next week, we'll continue on with this topic. Until then, have a great one.